Hey everyone, in today's video, I will be using BricsCAD to reverse engineer a broken chair leg and design a 3D printed brace to reinforce it. This project is a great way to learn reverse engineering in BricsCAD because the chair legs mounting faces aren't perpendicular. They are all set on different planes. To design a proper 3D printed bracket, you will need to scan it first. And the bracket design needs to hold up against a rotation along all three axes, which I have marked in red. Here is the chair I'm working on. It's made from inexpensive IKEA wood, and I have been using it for over 12 years. I've got 4 of them at home and another 8 in my rental units. So if this fix works, I save a lot by not having to replace them all. I'll be scanning the chair with the Creality Sermoon P1, the all-in-one laser scanner, since I don't feel like hauling it up to my office. For smoother tracking, I start by scanning the markers using global marker mode. Then I switch over to cross-line laser mode and scan the point cloud at 0.3mm resolution. Slim profiles are always tricky to scan. Those sharp corners block the scanner's view when I try to rotate it. If you drop a few more markers around the corners, the scanner will track way better. There is a big update for the P1 that just dropped it today. I cover it in a separate video next week. The quickest way to pull data from the Sermoon P1 is with a USB-C cable. As you can see, it imports in just a second. Now I'm going to clean up the point cloud and fuse them. BricsCAD doesn't support ASC point cloud files directly, so I will use CloudCompare to convert them into LAS format first. Looking from the top, you can see the chair frame isn't perpendicular. The mounting faces aren't parallel either, which makes the geometry even trickier to work with. So I tried rotating the frame manually and align this rectangle with the X and Y axis. Exported the point cloud in LAS format. Alright, let's begin the tutorial. Click on the 3D modeling template. Since our imported point cloud uses a millimeter by default, down in the status bar, you can flip between workspaces. I'm sticking with the modeling workspace. Click the 3 dots button in the lower right corner and you will be able to enable dynamic UCS, line wake, and selection mode toggles in the status bar. Turn this on. You will use them often and it's much easier to access them here. Now you can easily toggle the selection mode. We have faces, edges, and boundary. I turn them all on and with one click in the status bar, they are enabled. This is the dynamic UCS toggle button. It lets you sketch directly on the detected plane without manually moving the UCS. I usually keep it off and only enable it when needed. Here's an important one, eSnap 3D. This tab lets you snap directly to point cloud data. Make sure it's turned on, and remember you will often need to toggle it on and off while working. You can use either the button or press F4. This is the 2D snapping tool. I have set mine like this and I always keep it on. For S-track, I usually keep it on, and the same goes for polar tracking. which I set to 90 degrees. Make sure both are enabled. As for dynamic UCS and selection mode, I only switch these on when I need them. Moving up the top, you will see the drafting and modeling tabs. These are the two you will use most often. For this tutorial, we won't be using any surface commands. There is also a mesh tab, but I don't recommend using mesh for CAD modeling. And today I give you a quick look at using the 2D parametric tool. When you click on the View tab and then Coordinates, you will see one of your most used tools, the UCS. BricsCAD has a very powerful UCS tool. It's the key to quickly creating sketches in 3D. The most commonly used options are UCS Face, UCS Z-axis, UCS Entity, UCS Origin, UCS 3 points, and UCS Rotate. We'll be using all of this in this tutorial. In the Point Cloud tab, this is where you import your point cloud. The commands you will use most often are crop and uncrop. I will right-click on the right menu tab, go to Toolbar, then BricsCAD, choose More, and open the two menus I use most, Point Cloud and UCS Options. Then I drag these two menus to the top so I can access them with a single click. Here's the final setting. Right-click on the View Cube, select View Style, uncheck WCS and check UCS instead. This aligns your viewport with the current UCS, making sketch tracing much easier. Now everything is set and we can move on to the next step, importing the point cloud. Click on the Layer tab. I'm going to create two new layers, one for sketches with line thickness set to 0.3 mm and another called Solid. I keep all solids in that layer separate from the sketch so I can toggle them on and off easily. Next, go to the Point Cloud tab, choose Import, select Process File, and open your downloaded 3D scan point cloud. Leave all settings at their defaults, then click Attach. Click on Render Settings and set the point size to 1. Next, we are going to move the point cloud to the origin point here. Next, I will activate the sketch layer, draw a rectangle, and add a line snippet to its midpoint so I can locate the center. I change the point display to circles and set that size to 1 mm. So this will be the work point of the point cloud, but I need to move them downward using the Move command. Just drag the sketch along the blue Z-axis. You see it when polar tracking is enabled. Next, I will select both the sketch and the point cloud and move them to the origin point 0, 0, 0. Let me show you an example of when your scan data isn't aligned with an axis. I want to align the scan data with the y-axis here. I simply select the point cloud along with the sketch, click on Aligned, choose the first reference point, then the second. You don't need a third point, and when prompted, do not scale. Now your point cloud is aligned with the y-axis at 0 earlier. You can achieve the same in AutoCAD, but not in Autodesk Inventor. You can use layers to toggle the point cloud visibility on and off, and it's best to lock them once alignment is complete. On the left view, click the Point Cloud Crop command and select the top face. Enable 3D eSnap, then click on UCS 3 points, select 3 points on this face, and the XY plane will be repositioned onto it. Always remember to disable 3D eSnap once you are done. Create two lines, offset one of them, and then trim both ends. Copy one of the lines to the midpoint and drag one end along the length. You will see two dimensions input boxes. Press tab once and enter 60 for the length. Offset the line 5 mm on this side and 9 mm on the other side. Select the four lines and use the join command to combine them. Uncrop the point cloud, select the polyline and use the extrude command, pull it upward, enter 60 for the height, and then change the layer to solid. You can see that the box face is protruding into the chair leg. I'm going to create an intersection line here, align to the point cloud, then I will use the slice command. Select 3 points on this face and finally pick a point on the end to keep this side of the solid. Now the solid is flush with the chair leg. When you turn on selection mode, hover over this edge, activate the chamfer command and set it to 5 mm. Select this face, click offset and offset the boundary line by 4 mm. Move the line to the sketch layer so it's easier to see. Then move the UCS onto this face. Select these two edges and extract a line from them. Then extend these two lines until they meet the edge. Use the push-pull command and push this face downward by 10 mm. Move the UCS onto this face. Draw two lines, each 3 mm long, and then add a diagonal line. Use the push-pull command to cut this face away. Looking from the top view, the wall lines aren't parallel. I'm going to use this face to sketch the mounting hole. Click on UCS face and move it onto this plane. Draw a sketch line 5 mm to the right and 8 mm downward. Create a circle here with 4.5 mm diameter. You can use either the extrude or push-pull command to cut this face. Next, I move the UCS here and draw a 3.5 mm line. Shift the UCS to its tips. Then create another line 2.25 mm long and sketch a circle with a 4 mm radius. Then use the extrude command to cut the face away. Select this edge and apply a 2.5 mm chamfer. Move the UCS onto this face, then track an 8 mm line starting from the midpoint. Drop in a 4.5 mm circle, push-pull to cut it, and chamfer the edge 2 mm. Draw a line 15 mm along the edge. From this, construct a sketch, ensuring the short lines measure 2 mm. Join all the sketch lines into a close profile, then apply the extrude command with a 2 mm step. Just stretch one end of the solid like this and join it into the main body. Cut this face off using the push-pull command, then select the face and align it with the manipulate tool. Just snap it onto the intersection. Apply a 1.5 mm fillet to these two edges. Move the UCS onto this face and draw a 15 mm line downward. And at this sketch, the shorter line is 2 mm long. Join the sketch to close the loop and extrude it downward for 2 mm. Pull this face outward and model it similarly to the previous stiffener. The first bracket is now complete. Now I'm moving on to the second bracket. It's modeled similarly to the first, but positioned on a different plane. You can copy and modify the first bracket, but remodeling is faster. and you should practice modeling this one yourself. I'm going to use a 1-inch number 7 screw, so I need to make sure the screws don't collide between the two brackets. You can also experiment with 2D parametrics, which lets you move the sketch using the parametric manager. I prefer to set dimensions using construction lines in the sketch. It's quicker and feels like a drawing on a paper. The direct modeling tool in BricsCAD is excellent, and it really helps shorten modeling time. Just so you know, I'm not a BricsCAD expert. This is only my third time using it, and I have had it just for a week. Next, I will create a mount for the bracing bracket. I just pull out this 30mm face by 20mm. Do the same for the other bracket. Then I create two lines to define the bracket's layout. Then I use the project command to map those two lines onto the UCS plane. Then I created a sketch to define the cut. Next, I'm going to create a dovetail joint. Using construction lines, I defined the shape and dimensions of the dovetail: 60 degree, 4mm wide, and 4mm deep. You can even move the solid's face into the desired location. Since the edge was too close, I shift it 1mm to the right. This is a very flexible cut tool. Next, I will create the endpoint for the diagonal bracing, offsetting the dovetail cut by 0.1mm for the Creality. So I just mirror it, then use a line to snap it onto the opposite bracket. Next, I offset the edge 0.1mm and cut the dovetail on the other bracket. Alright, now I'm joining these two ends. They sit on different planes, so they don't line up. I just loft between them and then union the three bodies. It's simple, isn't it? Since the diagonal bracing can't lay flat on the build plate, I extracted the edges, flattened them onto this face, and extrude downward to create a flat surface for printing. With a bit of chamfer added, the bracket is now complete. And milling is super easy, no errors to worry about. And now the bracket is finished and ready for 3D printing. Because it's a tight fit, I don't need any adhesive, just a few taps and it locks in place. By the way, I printed this in a PETG. It's better suited for this kind of work. And that's it, a functional print made with a 3D scanner and reverse engineering. Thanks for tuning in.